Assalamu alaikum wa rahmatullahi wa barakatuhu. I welcome all of you, my dear friends from all over the world. Today we are talking about numericals of ionization enthalpy, and I will finish the examples maybe in 1 or 2 lectures. By the way, we will start our lesson by the name of Almighty God, the most compassionate and the most merciful. I mean, Bismillah ar-Rahman ar-Rahim. The first question that we have is ionization enthalpy and ionization energy are same or not? One thing more I have to say, if I write ionization and if I write ionization, both are same. This one we have the spell for the UK peoples, and this one we talk about US people. In US, ionization is written like this one, but in UK they write ionization with such a spell. By the way, I don't mean the spells, but we have to talk about the scientific methods or scientific effects of ionization enthalpy and ionization energy. What is ionization enthalpy and what is ionization energy? Ionization enthalpy, this is the minimum amount of energy which is given for an isolated atom for the last shell, the shell which its electron are less bounded to the atom, and we give the energy for the last shell to detach or remove its electron. What does it mean? It means we have an atom. This is the nucleus, and we have the shells. Suppose it's the last shell. Now from this last shell I want to remove the electron. Whatever I gave the energy and I want to remove this last electron, the atom should be isolated. What do you mean by isolated? It means it should be in gas state, and also it should be individual. It means there shouldn't be any bond between one atom and the next one. We should have an individual atom, and I want to remove the last electron, whatever energy I am giving to the atom. So this amount of energy which is less, which is not much more, this is called ionization enthalpy. But whenever you are talking about ionization energy, ionization energy is the amount of energy which is given for an isolated, what do you mean by isolated? Individual atom in gas state. This is also in gas state, in gaseous state, to remove the ground state electron. Ground state, it means first shell. For example, we have an atom. This is the first shell and second shell, or whatever we have. Now I want to remove this electron, not the last shells. whenever you want to remove this electron, and for this electron we should give an amount of energy, and you know that this electron is near to the nucleus. If this one is near to the nucleus, it is more bounded to the nucleus. If it is more bounded to the nucleus, so we should give large amount of energy to the atom. On that occasion, that energy which is given to the atom, and you want to remove this electron to infinity, it means you want to remove this one from the last shells too. It has been removing from the first shell, and you want to remove this electron to the infinity. So that amount of energy which you are giving, it's called ionization energy. From these two parts we have the result that ionization enthalpy, it is the minimum energy which is given to an atom, and ionization energy, it would be the maximum energy. Why? Because you are giving this one to the last electron, and you are giving this one to the ground state electron, and the ground state electrons, they are near to the nucleus, and we have more attraction between the nucleus and between the electrons. But in here we don't have more attraction between the last shell electron and between the nucleus. I think you have got. Write it down. Question number 2. Which element has the maximum ionization enthalpy in periodic table? We know the condition that if you want to go from left to right, Z or atomic number is increasing, ionization enthalpy is also increasing. If you want to go in groups from top to the bottom, size is increasing, ionization enthalpy is decreasing. Why? Because it is indirectly proportional to the size. Now if you think vice versa, it means from bottom to the top, size is decreasing, ionization enthalpy is increasing. Also in here in period, from left to right, ionization enthalpy is increasing. Now suppose this is the periodic table. We have here hydrogen, lithium, beryllium, and also sodium, for example potassium, or cesium, rubidium, francium, whatever, rubidium, cesium, francium. I think first one is rubidium, cesium, francium. In here, for example, we have boron, carbon, nitrogen, oxygen, fluorine, and also neon. In the top we have helium. Now in the groups, which element has the highest ionization enthalpy? The topest one. It means in here hydrogen. In this group we have boron. In this group we have beryllium. In this group nitrogen. In this group carbon, nitrogen. In this group oxygen. In this group fluorine. In this group not neon, helium, because it is on the topest location. Now from bottom to the top, hydrogen has, but among all the periodic table, not the topest, but we should go also in period. It means we should consider the condition of the period. Now if we want to consider the condition of the period, the topest is in the group, but in period, if you think, for example, in this period neon, In this period, maybe argon. In this period, maybe xenon. In this period is hydrogen. Helium. It means helium has maximum. It has maximum ionization enthalpy. Why? Because the first result that we can say, the first reason we can say is it is on the toppest of its group. Second, it is on the right side of the period. The toppest elements on the groups has got maximum ionization enthalpy. And also, if we consider the condition on the period, the right side has got more ionization enthalpy. For example, for the second period, we have the most one, neon. For the third period, we have argon. For the groups, hydrogen. For the groups, beryllium. For the groups, boron. For the last group, we have helium. Now, helium is on the toppest of its group, and also it is on the right side of the what? Of its period. For this result, we can say that ionization enthalpy of helium is the most one. I think you have got. Write it, please. Question number 3. Energy of an electron in the ground state of hydrogen atom is minus 2.18 multiply to the 10 to the power minus 18 joule. Calculate the ionization enthalpy of atomic hydrogen in terms of joule per mole. What does it mean? First, you should know the concept of the question. Second, you have to go to the solution. If you consider, for example, an atom of hydrogen, one atom. This is the nucleus, and we have the electrons in here. Now, this electron, which is revolving around its nucleus, the energy of this electron is minus 2.18 times 10 to the power minus 18 joule. Now, if you want to remove this electron, how much electron should we give to the atom? It means this part. It means we have to give 2.18 times to the 10 to the power minus 18 joule to remove the hydrogen. How much hydrogen? Just one atom of hydrogen. If you want to remove one electron, you should give such energy. Now, what is asked here? They asked calculate the ionization of atomic hydrogen in terms of joule per mole. It means if you do not consider one hydrogen, if you consider 1 mole of hydrogen, we have hydrogen, and this hydrogen, how much do we have? We have 1 mole. Now, for 1 mole, how much energy can we give to the hydrogen to remove its electron? For 1 hydrogen, you are giving this one. For 2 hydrogen, you multiply this amount of energy to the 2. For 10 hydrogens, we have to multiply this amount to the 10. For 100 hydrogens, we have to multiply this part to the 100, and for 1 mole we should multiply 1 mole to this amount, which is positive 2.18 times 10 to the power minus 18 joule. Now, what 1 mole is? 1 mole, it's a number. It's a number. how much of atom of the hydrogen we can call 1 mole? 6.022 times 10 to the power I think 23. This amount is called 1 mole, and I will multiply this one to 2.18 times 10 to the power minus 18. If you want to multiply this part, the answer is 1.312 times 10 to the power minus plus 6 joule. Multiply this one. If you want to multiply this part with this part, and we consider from these two bases 110, and you want to have the summation of the 23 with the minus 18, and the result will be this one. Now we can say for one hydrogen, if you want to remove one electron, we should give such amount of energy, and for 1 mole of hydrogen we should give such amount of energy to remove the last shell of hydrogen's electron. I think you have got it. Write it please. Question number 4. How would you explain the fact that the first ionization enthalpy of sodium is lower than the magnesium, but its second ionization enthalpy is higher than the magnesium? What does it mean? It means if you consider sodium, it has got 11 electrons and 11 protons. Now what's the electronic configuration? 1s2, 2s2, 2p6, 3s1. 2 plus 2, 4, 10, 11. Now whenever you're talking about magnesium, it has got 12 electrons. Electronic configuration: 1s2, 2s2, 2p6 and 3s2. In here, what's ionization enthalpy? Ionization enthalpy is amount of energy which is given to the atom in order to remove its last shell electron. Now it means from sodium, if this one is sodium, first shell, second shell and third shell, we have S and we have 1 electron in here. Whenever you're talking about magnesium, this is first shell, second shell, third shell, we have in here S. It has got how many electrons? 2 electrons. This one has got 1 electron. You want to give energy to remove its electron. You want to give energy to remove its electron. Now they are in the same shell but with different atomic number. It means in here the size are almost same but atomic number are different. Now ionization enthalpy is directly proportional to the Z. Whatever Z is, ionization enthalpy is increasing. Which Z is more? Magnesium. Since Z of magnesium is more than Z of sodium, so ionization enthalpy first of magnesium must be more than ionization enthalpy of sodium. Now whenever you're talking about second ionization enthalpy, it means the sodium is changed to sodium plus. Sodium plus has got 10 electrons. Now what's electronic configuration? 1s2, 2s2, 2p6. Magnesium changed to magnesium plus. It means it has 11 electrons. First it had 12. Now by removing 1 electron, it changed to the magnesium plus and it has 11 electrons. Now what's the electronic configuration? 1s2, 2s2, 2p6, 3s1. Now what do you think? What do you think? This changed to a stable electronic configuration. A stable electronic configuration. Like which atom? Like neon. It means it is 1:2, 2:2, and 2p6. Now you want to remove the electron from which orbital? From p, and it is half fill. I'm sorry, full fill. Now for full fill electronic configuration, I think ionization enthalpy is more. For this result, we can say ionization enthalpy second of the sodium, which is changed to the inert gas of neon, it is more than ionization enthalpy second of the magnesium. The first ionization of the magnesium, it's more than sodium, but the second ionization of the sodium is more than magnesium. Write it, please. Question number 5. What are the various factors due to which the ionization of the main group elements tends to decrease down the group? Tends, it means they want to decrease down in the groups. What does it mean? It means whenever you are going in group from top to bottom, why ionization enthalpy is decreasing. I have explained this one in our previous lectures. There are two factors. First, size. Whenever size is increasing, what does it mean? It means hydrogen, we have lithium, we have sodium, potassium, also rubidium, cesium, francium. Now for hydrogen, we have, this is the nucleus and first shell. We have in here lithium, it has got two shells. For example, for sodium, we have, this is the nucleus, and we have three shells. Now by adding the shell, the electrons I think distance is more. Whenever we have more distance, the attraction between the nucleus and this charge, in here we have proton and in here we have electron, whenever by increasing the distance between the protons and electrons, the force of attraction is decreasing. Why? Because of Coulomb force. F is equal to K Q1 Q2 upon to D square. It means this F is indirectly proportional to the D, to the square of D. If D is increasing, F is decreasing, because we have indirectly proportion between force and distance. Now the distance is increasing, it means the force of attraction is decreasing. If the force of attraction is decreasing, it means this electron is not more bounded to the proton. So by giving a small amount of energy to this atom, we can remove the last shell electron. Second, the second result is screen shielding. What does it mean? It means if we have this is the nucleus and this is the shells or orbits, whatever you want to say. Now, what do you think? If we have an electron in here, we have here s orbital, p orbital. Now the amount of orbitals, it is increasing. If they are increasing, they will shield the last electron to the proton. Now in here we have walls. We have walls which they cover the proton, and the attraction between this electron and this proton is decreasing. We have two reasons for this result. First is size and the second is screen shielding. These two results, I think they are working on the decreasing of ionization enthalpy in groups. I think you have got. Write it, please. The last question for today. Compare the ionization enthalpy of nitrogen and nitrogen plus. First, whenever we are talking about nitrogen, nitrogen has got 7 electrons. Now the electronic configuration is 1s2, 2s2, 2p, 3. 2 plus 2, 4, 4 and 3, it's 7. Now, whenever we are talking about nitrogen plus, it has got 6 electrons. Why? 1 electron has been removed. So electronic configuration 1s2, 2s2, 2p2. Now in here, for nitrogen, we have 2 shells or orbits. We have S and we have P. In P, we have 3 electrons. It means this is half filled. But whenever you are talking about nitrogen plus, it has got how many shells? 2 shells. We have S, 2 electrons, and we have P with 2 electrons. What do you think? From electronic configuration, we can compare that ionization enthalpy first of nitrogen is more than ionization enthalpy second of the nitrogen plus. Why? Because it has a stable electronic configuration and this one doesn't have any stable electronic configuration. But this one is wrong. It's wrong. Note, for the same atom, do not concentrate on electronic configuration. For the same atom, what does it mean? This is also nitrogen, this is also nitrogen. This one is also nitrogen, this one is also nitrogen. It means we should concentrate on successive ionization enthalpy. In successive ionization enthalpy, we have explained that ionization enthalpy second is more than ionization enthalpy of the first. Why? Because this one is a ion and this is a I think this is an atom which has neutral charge. It has a charge in here. Why? Because it has lost it. It's an ion. For the ion, we should give more energy. By the way, basic, you can say that for the same atom, do not concentrate on electronic configuration. Whatever is, this is nitrogen. The second one is also nitrogen. If I say nitrogen plus and nitrogen 2 plus, now which ionization enthalpy is more? Ionization enthalpy of nitrogen plus is more than this one is more than this one, and this one is ionization enthalpy 3, ionization enthalpy second, and ionization enthalpy first. Do not concentrate on the electronic configuration. Simply we can say, if you want to compare, for example, maybe for another atom, like what? Like for example carbon and carbon plus. Do not concentrate on electronic configuration. Carbon plus has got more ionization enthalpy than carbon. Just focus on successive ionization enthalpy. I think you have got. By the way, we will have one more lecture relation between ionization enthalpy and also the characteristic of the metal and non-metal of elements. What's that relation between ionization enthalpy and the characteristic of metal and non-metal of elements? Wait for the next lecture. We will see inshallah. I love you all. By the way, Allah Hafiz.